Good. Okay, so only one question was left in the last class, okay, from this chapter, and then we'll be
Sir, we are doing
starting.
microorganisms.
We are almost done with this chapter. Discussion of the chapter has been done. We have done some sample question from this.
On
This
this.
question regarding the nitrogen cycle, sorry, regarding the nitrogen cycle that is left to be done. So let's do this, and we are going to move to the next topic. Okay. Before we do this diagram, like there are some empty spaces in it. There are some blank spaces that we need to fill. Let's discuss like what exactly is nitrogen cycle. Okay. So as you guys know, that nitrogen is one of the important nutrient required by the plants, right? What exactly is nitrogen required? It is required for the manufacturing of
Protein.
proteins. Exactly. Nitrogen, it is needed for manufacture of proteins as well as DNA, right now? For manufacture of protein and DNA, in fact, in every living organism, proteins and DNA are made up of nitrogen. Without nitrogen, protein and DNA cannot be made. Okay. Why don't you guys turn your cameras on? Aman, Abu Bakr. So for manufacturing of this, it is needed. Although we know that air contains almost 78% nitrogen in it, right now, nitrogen makes up about 78% of the air. But most organisms cannot use nitrogen directly from the atmosphere, right now. If we need nitrogen, like we humans also need nitrogen, are we able to take it directly from the air, or do we consume animal meat or eggs or beans like rajma to get it? The battery is low. Okay, no issue. Connect it to the charger, by the way. Getting it now. So most of the organisms are not able to get it directly from the air, including the plants. Getting it? So thereby, the nitrogen cycle is the process by which nitrogen is going to move between the atmosphere. From the atmosphere, it goes into the, like it will be moving in between atmosphere, soil, animals, and then from animal back to atmosphere. So cycle of nitrogen continues in this manner. It's a process where nitrogen is moving in between atmosphere, soil, plants, animals, and then back to the atmosphere. Getting it, guys?
Sir, I still didn't understand
Mm-hmm.
the nitrogen.
The
So the nitrogen cycle.
Yeah, I haven't even completed the explanation yet. Hold on. I'm just telling you in short, like what exactly nitrogen cycle means. Like nitrogen is needed for manufacturing of protein and DNA. Every living organisms contain protein and DNA in them. Although our atmosphere contains 78% nitrogen, but we cannot get nitrogen directly from the air. What nitrogen cycle is basically, it's a movement of nitrogen in between the atmosphere, soil, animals, and back to atmosphere. To talk about in detail, like what exactly happens in it, what are the different steps of nitrogen cycle. So the atmospheric nitrogen, I will need a new slide, hold on. See, step number one of nitrogen cycle is nitrogen fixation. It is, how are you, Aman? I mean, just Mustafa was, how are you?
Fine, sir.
Nitrogen fixation. So nitrogen fixation in this atmospheric nitrogen is converted into usable forms, into forms which the roots of the plants can absorb. What happens here in this, N2 is getting converted into usable forms like ammonia, ammonia, nitrates like NO3, that is nitrates, or into nitrites. That is NO2. Oh, I wrote the opposite. Hold on. Should be writing it here. See, the plants, they cannot take this atmospheric nitrogen directly. So it needs to be converted into these different usable forms. What do we call them? Yes, Doha, we call them as usable forms.
Usable.
Like the plants can use them. But when we are having atmospheric nitrogen, plant cannot use them. So it must be converted from atmospheric nitrogen into these usable forms, which the plants can take up from the soil and utilize it for the manufacturing of protein and for manufacturing of DNA for repairing itself. Getting it, everyone? Now the
Yes.
question is, how is it done? So it can be done in different ways. It can be done by lightning, right? Can be done by lightning, or it is done by the natural fixation. I mean to say by nitrogen fixation by the bacterias. Which bacteria am I referring to here? By
Clostridium bacteria.
exactly. Where is it found to be living?
In the root
So,
nodules
in the
of
root nodules
leguminous.
of leguminous plants.
Very good. So it is found living in the root nodules of leguminous plants. Good. Although there are some other bacteria also, like there are bacteria called as azotobacter also, but they are not found in root nodules, azotobacter, but they are directly found in the soil. Clear? Found in the soil. So they help in it. So that is the first step of nitrogen cycle. That is nitrogen fixation. In step number 2, let us understand what happens. Guys, if there happens to be any doubt, no, please let me know. Okay. Or if things are a bit complicated, please let me know about that also. So I will try to simplify it.
So how is it done by lightning?
How is it done? So basically, lightning breaks the bond between the nitrogen atoms, and then nitrogen will be combining with the oxygen to form compounds like nitrates or nitrites, or when it is broken down, it will be reacting with the hydrogen to form ammonia. Getting it? Like try to visualize it in the following manner. Like say that these are the two atoms of nitrogen, suppose, and when it is struck by lightning, so they break apart. Good evening. And both of them are nitrogen, they have broken apart, but nearby it, let's say there is some oxygen also. These are oxygen. Okay, so it kind of reacts with oxygen, so it will be either forming NO2 or NO3. It will be forming nitrates or nitrites like this. So
Okay, sir.
lightning basically breaks it, so it will be now free and it can react with other other atoms present in the air. We don't need to go there into detail. Where the another step was nitrification. It is nitrification. Now, in this, what happens? Ammonia, no, the ammonia is converted into nitrates and nitrites by nitrifying bacteria found living in the soil. In this, what is happening? Ammonia, that is NH3, is now being converted into nitrates and nitrites by a special type of bacteria found to be living in the soil, which we call as nitrifying bacteria. Okay, I really need the slide, that picture here. Otherwise, you guys will find it a bit difficult to understand. Hold on. Okay. Now I want all of you to look at this image here. Look here. This is atmospheric nitrogen, right? And it needs to be converted into usable forms, right now, like ammonia, nitrates, and nitrites. That is ammonia, nitrates, and nitrites. which the plants can take up. So the first step was nitrogen fixation. In nitrogen fixation, this atmospheric nitrogen is being converted into ammonia nitrates or nitrites. Second step is nitrification. So in the case of nitrification, what is happening? You guys pay attention over here. Look at these nitrifying bacteria. What are these nitrifying bacteria doing? They are converting ammonia. This is the chemical formula of ammonia, by the way, that is NH3. So nitrifying bacteria are converting ammonia into nitrates and nitrites. Getting it, everyone? Look at the arrows.
Yes, sir.
That is what I have written here. Ammonia is converted into nitrates and nitrites by the nitrifying bacteria. I hope there shouldn't be any confusion so far. Nitrogen.
Sir, in the image, why were there two arrows, one up to NO2, to nitrates and like can you like zoom in the picture?
Yeah, hold on. Why there are two?
So why are there two
Oh.
arrows for?
See,
I think
basically
it's something.
this upward arrow is showing here that this nitrate is being not taken up by the plant. Okay, now this compound is now being taken up by the plant. Getting it? That is what is being said. And then here, this NH4, which is also a compound of nitrogen, that is also further being converted into NO2. Getting it now? Like when the animal waste decomposes now, so they're also converted into nitrogenous compounds, like ammonium. That is ammonium. Okay, so that also further gets converted into nitrites. So that is why this arrow is being shown here, like the animal dung, animal poop. Okay. So the second step was nitrification. All right. After nitrification, another step, that is step number 3, is assimilation. I think you guys should be familiar with the term assimilation. In the topic digestion in humans, you would have learned about different steps of nutrition. So assimilation is basically absorption of nutrients now, remember? Absorption of nutrients,
Yes, sir.
and then it's transferred to
Yes.
different parts of the body. It's carried by the blood stream. Now, in this case, what is assimilation? This assimilation is that the plants will be absorbing the nitrates and nitrites. Plants absorb the nitrates and the nitrites from the soil, and then they'll be using it to make protein. Okay. Does that thing clear? What is assimilation here? So plants are absorbing
Yes, sir.
nitrates and nitrites. Look where I'm pointing, nitrates and nitrites, to use it to make protein. And animals, when they will be eating the plants, they will be getting nitrogen from them. That is the thing. So for this, I will be writing that plants absorb nitrates and nitrites from the soil and use it to make proteins. After step number 4, another step here is ammonification. Ammonification. So moments ago, as I was saying, you guys know that when plants will die, okay, no, like when plants will die, when the animals will die, or when animals will excrete the waste materials. So decomposers like bacteria and fungi will break down their proteins now, will break down their proteins, getting it into ammonium, right? And that ammonium further also gets converted into nitrite. So that is ammonification. So when plants and animals die, then when plants and animals die, or animals excrete the waste, then decomposers converts them into ammonium. Okay, so that is the process of ammonification. After this, you look over the denitrification here. So there are some bacteria which will convert this nitrate back into the atmospheric nitrogen. Some of the bacteria, what they will be doing, they will be converting these nitrates back into the atmospheric nitrogen. So nitrogen is now returning back to the atmosphere from the soil. Right now, earlier this atmospheric nitrogen was being absorbed into the soil via either via lightning or via the help of the nitrogen fixing bacteria like rhizobium. Okay, then it was being converted into useful compounds like nitrates and nitrites, which the plants can take up. When the plants and animals die, or when animals excrete their waste material, so their waste is converted into ammonium. Ammonium is also later on converted by the help of denitrifying bacteria into nitrite, which will be again taken up by the plant. Right now, and these compounds of nitrogen like nitrates and nitrites, some of them which were left in the soil, they, particularly this nitrate here, is being converted into atmospheric nitrogen by the help of these denitrifying bacteria, and hence the cycle completes in this manner. Also in this cycle, we are seeing that nitrogen is not only going through the soil but also going through the body of plant and the animal. Is that thing clear to everyone?
Yes, sir.
And what about the others who are silent?
Sir, can you explain step one, only step one?
Step one, see. So in the very first step, what is happening? Either due to lightning or either with the help of the nitrogen fixing bacteria, what is happening? The atmospheric nitrogen is being converted into useful compounds. Getting it now? It's being fixed into the soil. Like what this nitrogen fixing bacteria is doing, it's converting the atmospheric nitrogen into the ammonia. Later on, ammonia gets converted into nitrates and nitrites by the action of nitrifying bacteria. So in the very first step, atmospheric nitrogen is being fixed into the soil. And how is it being fixed? It's being converted into different usable forms. Okay. So that is nitrogen fixation. Step number 4, let me explain this quickly. So that is denitrification. So in this, you will write down that some bacteria converts nitrates back into N2. N2 is atmospheric nitrogen. Okay. So that was it. But suppose if 2 or 3 mark question comes, only 2 mark question comes, like if you have to define about nitrogen cycle in short, keeping it simple, then in short, what answer should you write down? This type of answer you will write down if a 5 mark question comes in exam, suppose. Well, you'll be elaborating all the steps. But in short, what we can say that nitrogen cycle here, nitrogen cycle is the natural process by which nitrogen moves between the atmosphere, soil, plants and animals and back to the atmosphere. It includes steps like nitrogen fixation, nitrification, assimilation, ammonification and denitrification. This cycle makes nitrogen available to all living organisms and maintains its balance in nature. Okay, now the balance of nitrogen in the atmosphere, that it is at 78%, that balance is also being maintained because of this nitrogen cycle. And this is important for maintaining the fertility of the soil also. Hope it is clear. Now let's complete this one. Yeah. So you have to complete the following cycle given in the figure. These are the blanks here. Okay. Look at the blank A, B, C, and D. All of you try to answer this. Just what should be there in the blank A? Atmospheric nitrogen is being converted into compounds of nitrogen in the soil. Or
Sir, it
here
can be ammonia, nitrates, and nitrates.
we have to name the steps here. What are the name of the steps? Like moments ago we had learned like nitrogen fixation, we have learned ammonification, denitrification, like that. No, so in that sense we should be answering it. What do
Nitrogen
we
fixation.
Nitrogen fixation.
nitrogen fixation exactly? No, so A is nitrogen fixation. Good. Look at
A
B.
question.
Yeah.
So does lightning directly convert into nitrates and nitrites, or first it converts it to ammonia?
No, first it converts it into ammonia. Getting it?
Yes,
Yeah.
sir.
Because when the lightning strikes her, because of the immense heat produced, sir, it is converted.
Exactly. It first breaks and then makes bonds with other molecules in the air, with other
Yes,
atoms
sir.
in the air. Good. So atmospheric nitrogen, look at this here, and here it is written bacteria fix nitrogen into nitrogenous compound. So what should it be there? Mm-hmm. Yes, anyone? Look at the C also. Animal eats plant. Compounds of nitrogen in the soil. What should be fill in this one? B,
Assimilation.
C. That is
So for C, I think it's assimilation.
for C1. No, uptake by the plants. That means
Sir,
assimilation. No,
the feces of the animal.
your feces. You are referring it. You are close to answer. Remember ammonification.
Oh,
Animals
yes.
Yes,
animals
sir.
eat plants, right? Okay, and when the animals will die, right, and when animals will be dying, so they will be decomposing, and that means ammonification will take place now when the nitrogenous compounds locked in their body will return back to the soil. So for C it is actually ammonification.
Therefore, D it is denitri.
Which one?
So for
So D is denitrification.
Exactly,
denitrification.
where compounds of nitrogen are converting back into atmospheric nitrogen. So exactly that is denitrification. Very good. Okay, only one is left. That is B.
So nitrification.
No, 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 no. See, atmospheric
So
nitrogen. First of
assimilation.
all, no, no, hold on. You guys look at this once again. The atmospheric nitrogen, first it is converted into ammonia now. Look here again.
Yes, sir.
Atmospheric nitrogen is first converted into ammonia now. So first product that is formed when nitrogen is fixed into the soil, it is ammonia actually. Later on, nitrates and nitrites are formed later on. It's not like immediately nitrates and nitrite forms. First ammonia forms and then comes another products. So that should be ammonia. It's not any step, but it's the name. Where is it? Of the product, and that is going to be ammonia. Okay.
Yes, sir.
Hold on. Just this one more thing. It's saying bacteria fix nitrogen into. Okay, sorry. It's actually talking about the bacteria, guys. Here, it's talking about the bacteria. I didn't look at it. So it's referring to the rhizobium bacteria. Remember, it's talking bacteria fix nitrogen into nitrogenous compound. No? So thereby, it's actually talking about the rhizobium bacteria. Okay.
That can be azotobacter as well, right?
Azotobacter also very good. Azotobacter, that also. So that is it. So here we have finished this chapter. Now let's do some question from the chapter coal and petroleum. Okay, now in this chapter, is there anyone who is having any doubts? Like Mustafa, you were talking about fractional distillation.
Yes.
Okay. Others also let me know if you have. Was it fractional or is it destructive? I think you were saying about
Distillation.
destructive of fractional. Repeat again.
The destructive distillation of coal.
Okay, okay, got it. See. Meanwhile, others may also tell me about their doubts. Okay.
So I have a doubt in fractional distillation.
In fractional distillation. Okay, good. Talking about the destructive distillation of coal, like what is the concept, how is it done, why is it done, what are the things to take care of, what is the end result of it, what products do we obtain, what are the uses of the different products obtained in this process. Let us understand this. As the process says, destructive distillation. So we are destructing something here, right? We are destructing something here. Okay. That is the context here. Destructive means we are destroying it, something, destroying it. And what does the concept of distillation mean? Distillation is the process of separating something now, right?
Yes.
It's the physical separation which purifies particularly the liquid mixtures, right now. So first we are going to destroy something, and later on distillation will also be carried out. So let us understand how exactly this process is being done. So concept is such that destructive distillation is the process of heating the coal strongly in the absence of air. As you can see here, we will take later on, it converts into powdered coal. That's a different thing, but initially we have taken some pieces of coal, and that was strongly heated in the absence of air. So we are heating the coal in absence of air, so we are destroying it. Now in this process, will the coal burn? Is it going to catch fire?
No, sir.
No. Why? Because
It's happening in
There's
the
no
absence of air.
presence of
exactly in the absence of air. So it is not going to burn, but rather it is going to break into useful products, right? So what are those useful products we are going to get? Coke, coal tar, and what else? Coal gas.
coal.
Coal
Okay.
gas.
So the word destructive means coal is decomposed into these different substances, and distillation means separation. The word distillation here means loosely we are referring it to separation. Destructive means we are decomposing it. Okay, we're decomposing it into these three different substances. Okay, so first coal has been placed into this airtight container, let's say into airtight tube. It is strongly heated at high temperature without oxygen or air. Since no air is present, so coal does not combust, it does not burns, but decomposes chemically. Okay, then different products are separated through pipes and chambers here. Take a look at this one here. So as it will be heated, so we will see that some vapors will start to arise out of it, because whatever volatile substances are right now, volatile substances refers to substances that can evaporate. Getting it now? Substances that will evaporate. So volatile substances will go from this boiling tube A to another tube, that is tube B, let's say tube B. Now in tube B, we had taken some water. Okay, now we had taken some water. So this gas, now this volatile substance that has evaporated from the coal and is coming into this, it has been made to pass into the water. Okay, so those volatile compounds, it contained different things in it. It was a mixture of different substances. Okay, so some of those substances were soluble in water, some of them were soluble in water. Okay, now so the substances that were soluble in water, they were two substances which we got in this. One substance was coal tar, which settled at the bottom, Another was the ammonical liquor. Okay. And the substance that was non-soluble in water, that did not dissolve in water, it escaped out of this test tube B from this delivering tube, and that was coal gas. How do we check for the release of coal gas? If you were to bring a lighted matchstick, so the flame of the matchstick will grow bigger as it is getting coal gas, which is a fuel. Okay, is it clear?
Yes, sir.
Yes.
Mustafa seems to have used. Do you have some doubt in it? Tell
No,
me.
sir.
Okay. Now the question is like, why is it done? Huh? Why is it done? What is the purpose of this? See, coal is not always directly used in the raw form. Although we use it in the we mostly like it, we use it in the raw form also, but many times we do not directly use it in the raw form, because by the destructive distillation method we will be able to obtain so many useful products from it. Okay, na? And they have got so many uses. They are more useful in industries and daily lives. Coal in its raw form is not as useful as these products obtained from coal are. Okay, now then one more question: what are the things to take care of while we are doing this activity?
So there should be no presence of
Absence of air, right?
yes.
There should be absence of air, otherwise coal will burn completely and only ash and carbon dioxide will be produced. Only ash and carbon dioxide will be produced if it is burned in presence of air. Okay, we have to take care of the proper temperature also in it, etc. Talking about the use of different substances obtained here, let's talk about the coke. Where is the coke obtained here? Where is coke? Here it is, right?
The body.
Yeah. So coke, it is in solid state and it is porous in nature. Porous, you understand? It means that it will
Yes.
allow water or another liquid to pass through it. Right? Now, porous means that, like you have seen a sponge, right? A sponge. Sponge allows water or air to pass through it, like that. So coke is solid and porous in nature and is almost pure form of carbon. Right now, it is almost pure form of carbon, like contains 98% of carbon only in it. Okay. It is used in various areas now. Do you guys remember the use of coke?
Yes,
It
sir.
is used in extraction of metals. Remember that.
Yes, sir.
In
In
extraction of
industries.
metals from their ores. From their ores. Okay. Do we not also use it for manufacturing of steel?
Yes, sir.
In
Yes,
steel
sir.
manufacturing also it
In
is needed,
steel
no?
and
Good. And in other industrial processes also it is used. Okay. What about the coal tar? What are its properties and its uses?
used in making paints, perfumes,
First, let's
synthetic
talk about its
fibers.
property. Yeah, that is correct though. Let's talk about its property first. Is it thin or thick?
So it's a thick black liquid.
Thick black
It's a
liquid.
risk.
Has got a very pleasant smell, right? Does it have a
Yes,
pleasant
sir.
smell? No. It has a unpleasant smell, right? It's a thick black liquid and has got a very unpleasant smell. Okay, good. Second is that it's a mixture of about how many different substances?
200 different compounds.
About 200 different substances. Then you were listing about the uses of it. Tell me what were the uses?
They used in making paints,
Hmm.
dyes, synthetic fibers,
Hmm.
and perfumes.
Plastic and perfumes, etc. Okay, now we are having the coal gas. Okay, so coal gas, it's a mixture of different substances. It is a mixture of a mixture of different substances, like it contains hydrogen, contains methane, and it contains carbon monoxide in it. So it's a mixture of different gases actually. Coal gas is the collective name of these things. Okay. So it is collected as a byproduct and it is used mainly for the purpose of heating and lighting. Okay, now earlier it was used for the purpose of lighting in the street lamps, but nowadays it is particularly used for the purpose of heating. Many times in some factories it is used as an industrial fuel. Okay. Now you had a doubt in this fractional distillation, right? Okay. First of all, let's understand the meaning of the word distillation. In your unit classes, you must have had learned about chapter separation of substances, right? Now, substances can be separated in different manner. You have sedimentation, decantation, distillation, right? Filtration, etc. So in distillation method, the concept here is that we separate the mixture of two or more than two different substances having different boiling points. Getting it now? Having different boiling points. Suppose you had a mixture of salt and water. Say you have taken salt water, right? Now salt and water, their boiling point is different now. Salt being solid while water liquid, so their boiling point is different, isn't it?
Yes.
So we will be heating the mixture to boiling point of that substance which is more closer. Like water has a lower boiling point in comparison to salt. Water evaporates at 100 degrees Celsius. So we are going to heat the mixture at at temperature of 100 degrees Celsius. So all the water will evaporate and it is now being made to pass through this condenser in which cool water is flowing. So thereby the water vapor will convert into water droplets and drop by drop it will be collected into the receiving flask. So that is the concept of distillation now. Another substance is left behind. So the core concept of distillation is that we are separating two or more than two substances because of difference in their boiling points. All right. So talking about the fractional distillation, the concept here is somewhat same. All right now. So first of all, in the oil refinery, crude oil is being heated in the furnace. As it is heated in the furnace, okay, so the different components get separated at different boiling points. Getting it, Dohan, everyone?
Yes, sir.
Okay. So let us understand like how it is done in detail. Okay. As you guys know that the crude oil, it's a mixture of so many substances in it. Now, it's a mixture of different substances. Of different substances. Can you guys use it in your car in its raw form?
No, sir.
No, we can't. No. Think about it. If you were to put crude oil in your engine, what will it do to the engine?
It will damage it.
It will
So
obviously,
it
it will damage it. No, getting it. No, crude oil, it's not a clean fuel. It's a mixture of so many hydrocarbons, sulfur compounds, heavy substances are there in it. So engines are not designed to burn materials like this. Okay. Also, there'll be incomplete combustion. It will clog the engine. Free fuel injectors will get clogged. Anyways, so talking about how it is carried on. So first of all, in the oil refinery, it is being heated. It will be first of all brought to a temperature of 20 degrees Celsius. The temperature will be maintained at 20 degrees Celsius. So substances that have a lower boiling point, like butane, propane, that is basically component of liquefied petroleum gas, they will evaporate and they will collect at the upper chamber, at the topmost chamber. And via this outlet, it will be taken out. As you guys know, when the vapors of the water, when they evaporate, so they condense. For example, you are boiling the water and you have taken a plate. Above the plate, you have placed some ice cubes. So when the vapors hit it, they convert into water droplets now, right? And then you can collect these water droplets. So somewhat same thing is being done here. When the vapors of butane and propane are rising up, so they are being collected into this chamber. So they will be condensing now, right? As they will cool down, they will condense and they'll be taken out from this outlet. Yes or no?
Yes,
You
sir.
can even look at this here, right? Their outlet from which it will be taken out. You can see different pipes are connected here. Okay. Now, when the temperature reaches 150 degrees Celsius, so petrol starts to boil, it evaporates and condenses in this chamber, and then it is taken out. Petrol is also known as gasoline. Now, when the temperature of the furnace have been risen to 200 degrees Celsius, so vapors of kerosene will rise, it will condense and will be taken out, and so on. Diesel and fuel oil. And now, when the temperature reaches 400 degrees Celsius, so then we get substances like lubricating oil, paraffin wax, asphalt. Asphalt is particularly used for manufacturing of, earlier it was particularly used for manufacturing of, I mean to say, roads. There it is useful. Although bitumen is also particularly used in the construction of roads. Is the concept clear?
Yes, sir.
Okay, so that was the concept of fractional distillation in short. Here you can look at the actual working of the oil refinery. How the vapors are rising, they get collected up, and then they are taken out. Okay. Any other doubts from anyone?
No, sir.
No, sir.
Okay. What is the full form of PCRA? Yeah.
Sir,
PCRA stands for, first word is petroleum. Another word is conservation. Petroleum conservation. Yes. Petroleum
Research
conservation
agency.
research association. Okay, now it refers for Petroleum Conservation Research Association. And what are the guidelines of PCRA? What does PCRA do and what are its guidelines? Yeah. This organization, now this association, it is a government body under the Ministry of Petroleum and Natural Gas. Its aim is to promote energy efficiency, and to raise awareness and take steps towards conservation of petroleum products in India, particularly. Getting what I'm trying to say?
Yes.
Conservation of petroleum. How the petroleum products can be used efficiently. Like, for example, if your car is operating on an engine that consumes so much of fuel, so is that energy efficiency? No, it isn't.
no, sir.
So PCRA, that is standing for Petroleum Conservation Research Association. Its aim is to promote energy efficiency in the country, to release guidelines for the people how they can conserve petroleum products, particularly petrol, kerosene, diesel, etc. Various guidelines have been issued by it. For example, if you are driving somewhere, so you try to drive at a constant and a moderate speed, right? Maintain proper air pressure in the tires. Regularly service your vehicle to improve its mileage. Switch off the engine when you are waiting for longer duration in the traffic. Getting it, everyone? Then,
Yes,
for
sir.
then we should be referring to alternate sources of energy also, like use solar cooker a solar heater, let's say, right? That is the thing. Let's do some questions from this chapter now. Okay. By the way, Aslam saying that it is important that whatever chapters we are doing here now, after the class, you guys read the chapter, go through the different concepts. While you will be reading now, then only you will be able to find out whether you are having any doubts or not. That is one of the way. Another way to find out whether you are having any doubts or whether all your concepts are clear or not will be like once you will do some questions now, then it will become clear to you. Okay. So first question is, you guys explain what is coal and what are its properties. Yes, everyone answer this.
Sir, coal is hard. Sir, coal is
Is it a fossil fuel?
yes, sir, coal is a fossil fuel that is formed under the earth millions and millions of years ago.
Okay. Others also answer the same simple question. So that this carries 2 marks. Yeah. For a 2-mark question, you should be at least writing 4 lines.
So it is hard and black in color.
Okay. You can add that it mostly contains carbon in it.
It mostly contains carbon in it, but contains some amount of hydrogen and oxygen,
And sulfur
and some
also.
amount of
Continue.
and sulfur.
Then, yes, Abu Bakr, what about you guys? Priyanka?
Sir?
Yes. Is coal combustible in nature?
Yes, sir.
Right now? So we will write down that also it is combustible in nature. So when coal burns in the air, what does it give? Coal that
Heat
mainly
and light.
contains heat. Okay. I
And
mean to say,
light.
hold on. Mm. When it is being heated, so it gives out carbon dioxide gas. When it is being heated, it reacts with oxygen and thereby it gives out carbon dioxide gas plus heat and gives out ash also, right? So we will write down that it is combustible substance, right? Now it is combustible substance and gives out carbon dioxide and ash upon burning. So the answer for this question would be coal is a fossil fuel and a form of sedimentary rock. Okay. And a form of sedimentary rock that was formed from the remains of plants or animals. Tell me.
Sir, plants.
That was formed from the remains of plants buried under the earth millions of years ago. You guys write down the question and the answer. Billions of years ago. So here, what is coal? That question have been addressed. Next, we will be writing properties of coal. So properties of coal. So what properties are there? As you guys answer, it is hard, black, combustible. It has high amount of carbon in it. And when it is burned, it gives heat and light. These are the properties of coal, isn't it? Okay. It is hard, black, combustible substance. Okay. Second point I'm writing here. Okay, now there isn't enough space there. The second point is it has high amount of carbon in it and contains some other substances like sulfur, hydrogen, oxygen, as you mentioned. So it has a high carbon content. All of you are required to write it down. Aman, Priyanka, Abu Bakr, Mustafa, all of you.
Yes, sir.
Content and bonds to produce heat, light, and carbon dioxide. Okay. So that will be the answer for the 2-mark question. By the way, do you guys read novel? Anyone here who likes reading novels?
Yes, sir.
Good. How many books you guys have finished in the last 3 months? Any book, whether it be your course book, any novel, any storybook, or anything.
I finished one novel.
One novel. Good. What about others?
Sir, it will be like 25 books or something.
25 books.
Yes, sir.
Oh, that's good. That's really good. Very good. Abu Bakr. And
Sir, I read one.
repeat again.
Sir, I read one novel.
You have read. You have also good. Good. That's good. Finish it quickly.
Done, sir.
Done. Good. So as you are done, you do one thing. You answer to me what are the different types of coal based on its quality.
So there are four main types of coal based
Hmm.
on their carbon content.
Hmm.
First, there is peat coal, which has 60% carbon content. It is found closer to the earth than the other types of coal.
Hmm.
Then lignite coal has 65 to 70% carbon content.
Hmm.
Bituminous coal has 70 to 85% carbon content. It's a good it's a good quality of coal and is used in industries.
Hmm.
And anthracite coal has 86 to 92% carbon in it.
Hmm.
It is also it's the best quality of coal.
Hmm. Very good. Good. Okay. What are the disadvantages of using fossil fuel?
So they release a lot of toxic gases in the air, which harms the environment.
Okay. They
So
release.
they are
Hmm.
they're very limited. So in the future, there will be less when the fossil fuels will be finished. Then
They will get exhausted in future.
yes, so they'll be exhausted in the future.
Hmm. So as you were talking, like they releases toxic gases, so they cause air pollution. And how does air pollution affect us? So they leads to respiratory diseases, respiratory problems, right now. So they cause air pollution by releasing toxic airs like carbon monoxide, right, and other harmful gases, which leads to respiratory diseases. Okay, and they release carbon dioxide. Majorly, they release carbon dioxide upon being burned, and carbon dioxide is one of the greenhouse gas, and that leads to global warming, right? Okay, that's the thing. Everyone is done now.
So 1 minute.
Yes.
Okay. Okay. Abu Bakr, you answer to me. What are the different ways to conserve the use of, what are the different ways to conserve coal and petroleum? Suggest some ways. And Mustafa, you will be required to differentiate between renewable and non-renewable sources of energy with some examples. Hurry up.
That
Which fuel is used in aviation industry? Doha, you answer this. In the aviation industry, which fuel is particularly used?
So petroleum.
Petroleum is
Sorry,
the
sir, not
collective
petrol.
name. Which fuel is also called as aviation fuel? Anyone? Starts with
Sir,
K.
so kerosene.
Kerosene. Good. Here, Abu Bakr, answer. What are the different, suggest some ways to conserve coal and petroleum? Anyone?
So we should only use coal and petroleum when necessary.
Rather, you should start by answering like use public transport instead of private vehicles. Include those points.
Yes.
Switch off engines at the traffic lights. And we should be switching towards the alternate sources of energy now. What are the alternate sources of energy? Like solar energy, wind energy, right now? That is the thing. Yeah. And Mustafa, quickly differentiate between the renewable and non-renewable sources of energy. How are they different?
The renewable sources of energy are those sources which can never be exhausted,
Hmm,
and they're not endangered to be exhausted.
good. So they can be replenished naturally in the short time, right?
Yes.
They are in abundant quantity. Good. What are some examples?
Solar energy, wind energy,
Wind, water, sunlight, soil, etc. And what about non-renewable?
the non-renewable sources of energy are those sources which
Hmm,
can be exhausted very easily
hmm,
and are not available in abundant quantity to us.
hmm, hmm. So they are found in limited quantity. Oh, Priyanka, you can then leave the class if you have to go. Okay. We're about to end the class, by the way. Okay. And the examples are coal, petroleum, natural gas. Okay. Okay. So we are not done. We have